So, hello everybody. I'm Nils Aellen. Thank you for being here for this presentation. I will talk today about how to process big files with reactive streams. A little agenda. First, I will show you how we make eVoting in the Swiss Post, what we do. Then I will show you what we do for the pre- and post-vote integration, and then what we deliver, what we develop to find a solution for this for our problems. So first element, key points of our eVoting solution. There is already currently one productive application which is used by several cantons in Switzerland. This version that is productive uses the individual verifiability. That seems that the voter gets some codes attached to an answer to verify that the encrypted votes that is going to the urn is the one he chooses. There is also currently an application which is in development now, which is valid for the 100% of the electorate. And this application, which is in development, uses the individual verifiability, like the 50% above, and also the universal verifiability. The universal verifiability is the basic that the application will produce proofs during all the vote process, and we have to verify all the proof at the end to ensure that the vote is correct and nobody or nothing makes some mistakes. About the governance, we have to say that all sensitive data stays always in the cantons. That will be the decryption key, for example, is just splitted to members of an electoral council. They have smart cards, they just have a part of the decryption key, and they have to meet at the end to make the decryption. And another thing that is also important to know is that the encryption is made on your browser with a JavaScript process, and the security, the encryption is not only the HTTPS tunnel. So we made an encryption, and then the encrypted ballot is going through also an HTTPS tunnel. So in the post environment, we never have unencrypted data. Oh, sorry. Just to explain about the whole voting landscape, there is 3 steps. The first is the preparation. We have to prepare an election. We have to pack the element. Then the voters can vote, and at the end we get the result and we make the post-processing. In the normal processing, we have to first prepare the register, take all people which have the right to vote, and then we have to prepare also and ship the vote material. That is typically the envelopes you get at home. And then you can either go to the voting room on the Sunday, or you can also ship your vote by mail. And afterwards, we have to count all the results for each counting circles, and then we have to make a consolidation, because many accounting circles, for example, each municipality is counting, and at the end we want to get the result for all the cantons. And then the chancellery will publish the results, and at the end we will make a destruction of all the voting materials. If we add now the eVoting process, first, when we prepare the register, we have to anonymize all the voters. We just want don't want to have address, to have a name. We just want to say, okay, we have one voter, and he has rights to do that. It's only one element we want to know. Then by the preparation of the voting material, we have to generate the test codes. It's for each answer we generate a code, which can be from the encrypted value at the end regenerated, so the user can verify that in the ballot box it's the vote he wanted to put that is in the ballot box. And then we have to configure and initialize the e-voting system. Then we can also vote electronically, and after the vote we have to cleanse the ballot box. So it's to remove all the votes that were not finished, and then mixing all the elements, and at the end decrypt and then counting. And we have also a wiping process at the end, so like in the normal strategy to destroy all the voting material. What is the solution overview? We can so on the left there is the pre-vote element. First, some cantons are coming with data, and then we have to package all the data to configure the voting system. So the voting system is this one in green. And at the end of the vote, we have to get data from the voting system out to the canton with the results. One thing for today is that this element, the voting server, is concerned actually by the public intrusion test. This software is engineered by our technical partner, so for today it's out of this presentation. I will mainly speak about the Gravity application that we use in the pre-vote and the post-vote process to integrate all cantons with our systems. So first, when the first canton comes, business analysts make a small analysis of the process that we need to be able to configure the system. It's a big shit, so we have to say that, and it's not possibly to configure that. We say, okay, all this part we want to make an application which automatically makes the process, and for that, okay, we simplify the process with an application that must be able, in one release, to match for all cantons. Our application is named Gravity. So we take data from the cantons. Mainly, it can be CSV, XML files, or just proprietary file. And there is a standard in the eGov in Switzerland. It's ETH format. But we also have a problem because there is many versions of this format, and cantons are not aligned. Some are coming with version 2, some others with version 3, for example. And also, even if the syntax of the files are correct, so the XSD validation is okay, sometimes we have problem with the semantic of the files because data containing are not matching what we expect. And then we have to keep all this data to generate 4 types of data: the contest, the register, the cantonal structure, and some parameters, to at the end build one XML file which will configure the voting systems. I will come back to the 4 types of data. First, the contest. The contest is basically ETH 157 and 159 files. It contains either votes or elections. So the questions, what are the lists, the candidates to be elected. The register is mainly all the voters with their rights. Cantonal structure is all the municipality defined in district or whatever the canton is defined. And some parameters is just to define, okay, we want to have a default language, the ballot box will be opened from a date to another date, for example. About the weight of the data, for the parameters, we don't have so many problems because it only went 20 kilobytes, so that it's easy to read. The cantonal structure, it's about 1 megabyte, so for us it's not a problem to read. For the contest, it can be about 500 megabytes, so 500 megabytes is quite a lot, but we are able to read that. And the register for big cantons, it can come until to 10 gigabytes of data. And for us, for the analysis, we say, okay, perhaps there we have a problem. So what was the solution? We say, okay, all file we want to read, we will just stream the data. And so we engineered to create the solution. The is a Gravity project. We define some tools. Okay, we want to use Java. We want to stream XML files, so perhaps we have to use a streaming XML API, the Stacks2. We also want to use the reactive plumber. So reactive plumber use Groovy and Reactor. We also have to avoid for DTO to get to write and to read all the getter and setter. So we will use Lombok. XML merge is also a small tool to merge some different XML files in just one file, and mapstruct to convert data into another format, and also Cucumber for the test. At the end, we get a data flow with many steps, and all the possibility steps will be linked with a reactive plumber. So we have a plumbery of reactive streams. So at the end, we just want to drain from this element to take data, and that will be transformed. So we define that below the red line, we want to have standardized the data, and above, we will configure coming from the data of the canton. So above, we can add some elements to map to a standardized structure. And how is built this plumbery? For example, we can take a step, the register phase. And what makes this register phase? We can see that here we are using a reactor. So the reactive plumbery is just Groovy files. So you can see for one step we have one Groovy file. And okay, we can see is with the merge, we merge 3 elements. These 3 elements are the 3 sources that we can get here from there. And at the end, we want to output with one voter, with the voters, and the voter is just what we export at the end of the script. So it's easily configurable, modifiable, and we can at the end just say, okay, drain the plumbery, and we get all the files that we want. But in fact, we still have one problem, because just on the top we have an input phase which say, okay, on the source directory you have several files, and mainly XML files, and we want to get them into a FLUX from Reactor, for example. So our problematic is, okay, we have a file and we want to get them in a FLUX by making some pooling and not pushing data. So a FLUX, we know that we can create one by making a FLUX from iterable. So okay, we want to create, we have to create an iterable. From an XML file with the Stacks2 API, we know that we can create a reader. So we have a opening tag in XML, closing tag, and so. And to make the job, we have to build something in the middle using JAXB for the deserialization of the objects, and to create an iterable, perhaps to work with an iterator. So at the end, we want a signature. To create an extractor, we can give in parameters the source file, the XML file. Also, it's interesting to give the XSD file, XSD location, so we can also directly stream the data by reading them and validate them. And also, we want to make some deserialization with JAX-B, so we have to know which is the object factory class. So at the end, we have to, okay, I want to process this file. I want to get all these elements that are defined by an XPath and convert them direct into a class. If we go in the source code, we can see that in the constructor we just defined the JAX-B context, so the deserializer, the unmarshaller. And then we define the factory for stacks2 and then define the reader. So we are able to stream XML files, but just to stream XML tags. And if we get a XSD, we want to be able to validate it while reading, and not to make once a validation and then to read again the file to make the job. And okay, then we have, okay, process this path, give me this object of this class into an iterable. I know that the result must be an iterable. What is this iterable? So an iterable just implements an interface that gives an iterator. So I get forward to the iterator. An iterator just implements two methods, as next and the next method. And in the as next method, we want to process the job to find the next element that we want. We keep it in cache. So when we are going to the next, we ask for the next element. We can just first ensure that the as next has been called, and then return the next that was cached. And we just say to the system, okay, we don't have value in cache. When you just ask for the next one, we have to process again. So the magic process will be in this process method, sorry. This process method is just processing the stacks2 reader. And with stacks2 reader, we get some information. This is a start element, this is a stop element, an end element. So we have to make like a stack to know, to rebuild the XPath just we are analyzing. And this is the actual path. In this one, this is just a list to stack the element we are just analyzing. And when we match, this is the element we want to unmarshal. Then we just ask JAX-B, giving the reader in parameter to get the element and to unmarshal this. And otherwise, if we do all the file and we can get the elements, we just return null. So we were able to pull data by reading an XML, by reading a full XML file, by just reading the element. But we also have a problematic that sometimes we don't have only in a file. For example, we have many voters. We perhaps also have a header. And this header is also interesting for us to have it, to know what contains the element. And we don't want to just process the file twice. So we had also a push functionality in the process. So we can add element listener. So we say, okay, to this XML, to this XPath, I want to, if you find this XPath, I want to get the element, convert into this class, and I give you the consumer so you can call me when you find the element. It's just the element first, the add element listener. And then you just process the file. We had also a possibility to process the file just for pushing and not for pulling. And we had it's the same method from before, but we just add the element, okay, is that an element step that we are looking for? And if yes, okay, we just get the consumer and we accept it with the object. So we can get the object. Yes. So I am at the end of my presentation. Thank you very much.